Welcome back, everybody, to the hybrid section of today. So as of now, we're also on YouTube, so please do not swear.
We're online.
We're online? Yes. So swear all you want. No. Yeah, introducing our first speaker of today, Sam. Thanks for coming all the way from the UK to speak to us about AI and Terraform.
Thank you very much. Yeah, thank you for having me. This session for the Amsterdam Hug is teaching AI to Terraform so that you don't have to. My name, in case you didn't see what I look like, you can see a picture of me there as well, but I wasn't sure what else to put in the template. My name's Sam McGeown, and I'm a developer advocate at HashiCorp. I have spent many years as a sort of VMware infrastructure engineer, and then a consultant, then as technical marketer, a product manager, and I most recently joined HashiCorp as a developer advocate. You could say that the common thread throughout all of my kind of long career has been the automation thread, and that's really something that I really enjoy doing is automating processes and making stuff easier for everyone. So that is who I am. I'm going to talk about MCP servers. So show of hands. The other thing I should warn you is that I do prefer a little bit of interaction. So if you've come to sort of have a snooze this afternoon, I'd prefer if you just talk to me. So I might ask you questions. But in a show of hands, how many people here are using an LLM, AI, ChatGPT in some context in their professional life today? Most people, right? So you've got that baseline experience. So we don't need to talk about that. How many people have used an MCP server with their AI chatbot? A handful. How many people are kind of familiar with what an MCP server is and does? Couple more. Okay, so I have 3 slides, and I promise it's just 3 slides, and then I will get to like doing some demos and having some fun. And I definitely need some interaction with you when we get to that bit. So, what are MCP servers? Okay, so basically, if you look at modelcontextprotocol.io, which is a lovely domain that is really easy to remember, they'll tell you that to think of MCP as a USB-C port for AI applications. So it's in effect a kind of pluggable universal interface to allow you to provide information and tools and context to your LLM. So your generically trained LLM is trained on a model of data set. And if you want to provide that LLM with some context, with maybe some information about what you want it to do, you've got really 2 options. The first one is that you can build your own model using all sorts of really advanced data science and training it on documentation sets and stuff that most of us probably don't really want to get in the weeds on. Or you can use an MCP server. And it was actually developed by Anthropic, who is, as most people are aware, are one of the big players in the AI game at the moment. But it was created as a standard interface, so hence the USB kind of analogy for plugging in information into those models. It allows you to have this kind of structured and safe and extensible integration into your LLM model without you having to kind of write your own code and custom plugins and everything. So the idea being that when you run an MCP server, it's providing with interoperability, so allowing AI systems to connect to same tools with shared protocol. Security, and this is a really interesting part of it, because you can have your MCP server running in isolation, and your MCP server that's talking to a specific tool or endpoint can have its own security context. And that means that your LLM can't actually do anything without the MCP server being the gatekeeper for that. And that, when we come to talk a little bit later about like the different ways you can consume the MCP servers, that's one of the most critical kind of things that might push you to, say, hosting a service for an MCP server rather than having developers running MCP servers on your laptop. But I won't jump too far ahead there. So extensibility, we've kind of mentioned that a little bit. Basically, you can, if you're wanting to give specific functionality to your LLM, and then also consistency, so you can provide recipes and you can provide like a cookbook of processes that maybe 3 or 4 tasks strung together that you want to perform the same every single time you use your LLM to do something. So that's the kind of why of MCP servers. And I should say, right, my journey with MCP and learning all this stuff was very recent, and I'm learning in public. I'm speaking what I know now. Other people might correct me or have a better way of putting stuff. So take this as a starting point rather than the gospel of MCP servers. So how does the MCP server communicate? How does it work? Well, if you look at this diagram, on the left-hand side, you've got your MCP host or your client. Now, you can think of that as like your LLM, but you could also think of that like Visual Studio Code or Claude or any of the kind of vibe coding platforms, anything really that is invoking your LLM. It's going to communicate with an MCP server, which is the kind of binary that we're running that has all the instructions. And the way it communicates with that MCP server is over a kind of JSON RPC call. And typically, there are 2 supported ways for that to happen. The first one is the way that will happen if you're running your MCP server locally, say, with Visual Studio Code, and you've got a Docker container running or some container running. It's going to use standard I/O, and it's going to do that JSON RPC call directly to that local container. The other one is a streamable HTTP, and that's when, for example, if you were to run it as a service somewhere else, it would communicate over that HTTP protocol using a series of posts. But what that does allow for you to do is to have, say, authentication, your own authentication layer in front of that HTTP service. So you could send an OAuth token to identify yourself. So the MCP host would identify itself to the MCP server in that initial communication. So that means that you could have an MCP server authorized for a certain group of people or a certain application, and that MCP server then has the context and permissions to go out to whatever it's talking to, but you also need to authenticate there. So it allows you to provide a layer of security over the top of that. And then what the MCP server provides are tools, resources, and prompts. And is the text readable? Yeah, just about. So tools are like executable functions, and I'm going to show you some of those in a minute. So actions that you can perform on whatever API whatever your MCP server is fronting. Resources, basically a data source, something that you can query, and then prompts are those recipes where you want it to perform in a specific way or to perform actions in a series, as I mentioned, like those recipes before. So those are the 3 things that the MCP server is going to scope out to your LLM. And I promised you that it was only 3 slides, and that is the end of my 3rd slide. So what we're going to do now is jump over to a demo, and hopefully we can start having some fun with a little bit of code. And this is where I want some ideas and interaction for you, because the way it's going to work best is if I know nothing about it, and the interaction between MCP and LLM is the thing that actually we're proving that it's worked. I'm not pre-baking an idea into it or instructions. So, is that text big enough for everyone, or should I make it a little bit bigger? Can we read? Bigger? Bigger at the back. Let's try this. Is that better? Okay, cool. So, what do I have here? I have pre-made here a Git repository. called Terraform MCP demo. In that is a README file which was generated by GitHub. It's basically empty except for the title of the repository. And then I've added to it this VS Code folder, which is green, it's not checked in. And then I have a JSON file here that's configuring my MCP. I should mention that I'm going to use the Terraform MCP server, but there's also a Vault MCP server and there's a Vault Radar MCP server. So they'll obviously expose different functionality within Vault or within Vault Radar, but there are more than the Terraform MCP server. So when we're looking to start working with an agent or with an MCP server, we want to configure that how we're going to run it, and the way we do that is either you can configure your VS Code to have a general configuration, so you can actually edit the config JSON, and you can put the server settings into your kind of whole setup. And if you can then synchronize that between like multiple workstations and do all the normal stuff you can do with VS Code's configuration, or you can configure things on a per workspace setup, and that is probably the way that I've used it most, because if I'm doing something in Terraform, I might want the Terraform MCP server to be running in that particular workspace, but if I'm writing something in Golang, I don't necessarily want to have the Terraform stuff running. So it just allows me to configure that workspace in the way that I want very specifically. And so I'm going to start with, so this is all commented out. Nothing's running at the moment. I have Copilot running, and I've selected Claude Sonnet because that is pretty good at writing Terraform code out of the box. And then we can ask Claude Sonnet to build us a Terraform environment. So what I typically do is say, hey, build me a Terraform code to deploy a 3-node web service on AWS with a load balancer, database backend, and a middleware in between. And Claude Sonnet by itself will make a reasonable stab at that. That's pretty basic. When you start getting slightly more complicated, you're starting to use modules, you're starting to use different, less frequently used providers. What will happen is, as is the way with these things, you'll start getting slight hallucinations. Maybe it'll tell you that there's a provider service that doesn't actually exist, or it'll be using a module that it's made up by just out of thin air because it thinks it should be there. And this is where the MCP server comes in, because what that allows us to do is query the existing providers. It allows us to query publicly available modules, best practices, documentation. There's a whole bunch of stuff. So I've got this quoted out here. If we have a look at this code, I'll show you. So you can run this. So you can generate this code by hitting add server, and it will walk you through the prompt. So it will say, do you want to run it as a command with standard IO, or do you want to run a HTTP one? It'll then prompt you for the command if you're running a Docker command, or the URL if you're running a service. It'll also allow you to add environment variables and pass environment variables in and that sort of thing. I've got this configured here, so I'm not going to run through that wizard. So you can see here I'm defining an array of servers. I've called this one Terraform Podman. Being a good IBM employee, I'm using Podman and not Docker. But if you were to change the Podman to Docker, for example, you would find that it worked in exactly the same way there. So we've got our command is Podman, and then the arguments are I want to run, interactive, delete it when it's finished, pass it an environment variable, The environment variable I'm passing it is my Terraform token, Terraform Enterprise token or Terraform Cloud token, and then the name of the image that I'm running. And that is almost the bare bones. You could get rid of the environment variables and the token and just run it completely without. So you don't actually need, in fact, let's do that. Let's run it without, and then I'll show you with. So that's the bare bones configuration. You could run it with the Docker command. If you have been following developments with, say, Apple containers, you could use the container command. And they're all designed to be ways of running containers that are consistent across with it, so the inputs are exactly the same across those commands. Now from here, if I save that configuration, you'll see that VS Code's added these details here. So it's added a start. So if I wanted to start the container, I can obviously hit start. It's saying it's exposing 34 tools, and there's a little more there. So let's have a little explore of what's being provided. So if I click on the tools for my AI interactions, I can scroll down and find my Terraform Podman group, and then we can see what's actually being exposed. So attaching a variable set to workspaces, create a run. So these are all tools to interact with either Terraform Enterprise or HCP. So Terraform in the cloud. We also have get latest. So these would be the resources. And so because we're retrieving information, it's a resource. We're retrieving, for example, the latest module version, providers, details for those. We can also get things like the modules and private modules. But much of this is relating to your enterprise or HCP environment. So what I'm going to do is revert my configuration back so that I can input an API key so that we can see some of this working. So here I've got my Terraform token, and that is all configured. I've saved that, so I can run that. And then, just so I'm not lying, we can have a look at Podman, and we can see that we have that container. Oops, clearing the wrong thing. Try that again. So we've got that container created 18 seconds ago. So my MCP server is running. Really simple. It's small, it's lightweight. There's no real harm in like thousands of developers all using that container on their laptops. Generally, if you don't have any requirement for being able to provide a limited scope to your MCP server, then you could just run that. If you're using Terraform open source, or well, not Terraform community, apologies, don't want to poke that sore spot. Terraform community, you can still pull down the latest modules that are publicly available. You can get all your best practices. It's all baked into that information within your Terraform MCP server. Now, so I have this now running. I have input a token to my HCP environment. Where is that? He says. So I have a workspace configured here called Terraform HCP demo, but you can see it's completely empty. It's got my README file. It doesn't have any variables. It doesn't have anything there. There are no runs. There's nothing. It's blank. It was literally created this morning or a day ago. So now if we go in and we ask Claude to build us. Someone give me a shout out. Give me something to build that's maybe a little bit more obscure than, say, 3-server AWS front end. Snowflake database with 3 nodes in it. Okay. So, sorry? 3 roles. Okay. So, create the Terraform code for a Snowflake database with 3 roles. Anything else? Any more complexity? Create users. Okay, so we'll need to be a bit more specific. Create users for each of the roles.
Through Vault.
Hmm?
Through Vault.
Through Vault.
Yeah, Vault has.
Okay. Now that might be stretching the complexity just that one bit more, especially as I don't have the Vault MCP server running, and I don't fancy setting it up right now. However, that would be good. I was trying to keep it simple in the scope of Terraform. Okay, any more complexity anyone want to add? Well, let's see what we get from this. So you'll be familiar with how Copilot starts working. It'll tell you what it's going to do. It's going to start making a list of tasks that it's going to go through. And let's just give it a bit more retail here. So what will happen is you can see here that it's actually talking, it's saying, right, get the latest provider version. And so what we can see is it's communicating with my Podman MCP server, and it's found the latest provider from Snowflake Labs. It's version 1.0.5. And then it's having a look at that, and it's saying, okay, what resources are available there? And then it's asking me, do I want to allow it to do this? Now, what I'm going to say here is I'm going to say allow tools from the MCP server without review in this session, because I don't want to click allow, and we'll let it process, and we can talk through what it's happening. But this gives you control over what it's asking your MCP server to do. So if you remember that your MCP server is running in a context, if that context is privileged, you don't just want to let it go, you want to review it and have a look at what's happening before you kind of let it just go and blow up production. So we'll allow those for this session. So it's going out and getting the provider capabilities. It's having a look, and then it's starting to identify documentation. It's going to process. All of this is calls it's making to my MCP server. And if you want to get really nerdy, you can, I can't remember what the logs command is in Podman, is it? Podman log. Yeah. And then I'll give it the container ID, and we should be able to see that. So you can see that it's talking to documentation, and we can see that the MCP server is actually going out and doing what we're asking it to do. And Claude has come back. It's creating structure. It's creating the variables, outputs. It's creating all my example files. It's creating a README to start documenting the code. And we can actually start reviewing what it's been doing. So it's started populating the README. It's creating these 3 roles that you've asked for. It's creating 3 users. It's done sort of prerequisite documentation. It's got a bunch of variables. And then it's got the main provider. Now, what will happen is if you leave it as is, it will probably just keep building a bigger and bigger and bigger file with your main TF file, which is perhaps not the most efficient way to work once you start scaling up your Terraform code, as probably most of you have experienced. So if I say keep on this, one of the ways that we can control how the MCP works is by providing it with a set of instructions. So with an LLM, you can provide it with context instructions and ask it to do specific things or to do things in a certain order. And so one of the ways you can start to control how this MCP and LLM are working together is by creating a set of custom instructions. And so I'm not going to write out a set of instructions right now because it'll take a while, but there is on the MCP, the Terraform MCP server, there is some basic instructions to start working with. And if you kind of scroll through, it starts telling you, okay, this is what your capabilities are. This is how you start working. You can get latest provider versions and module versions, and it gives it a process and a structure to the way that it is going about the tasks. And eventually you'll get down to the end and it will say structure it this way, organize your code, split it into larger configurations, use different naming conventions. And all of this is like a bootstrap kind of set of instructions. You can actually go in and say, actually, when I want you to write code, I want you to do it in a certain way. And so you can give it instructions in sort of your language that it will understand. And eventually, this is quite long, but you basically get these Copilot instructions. Now, again, you can put these in various places within Visual Studio Code. I am going to put these for my workspace, so I'm going to create a new folder called .github, and then within that folder I'm going to create a new file, and I'm going to call it, what am I going to call it? Copilot instructions. .md. Okay, so I've created my instructions. I have not pasted in. I will paste in my instructions. Okay, but unless you know this context and you know what's been written, it's a little bit more difficult to understand what the actual changes are going to be happening. So let's make something really obvious. Okay, so in its basic agent instructions, we're going to say you will always speak like a pirate. So we're giving it really specific instructions. It's going to speak like a pirate. And then once we've saved that file, you can either restart your context or you can say reload the Copilot, if I could type, Copilot instructions file. And so hopefully it will do that.
Could you also change that to Yodish, so the language that Yoda speaks?
You could probably do so, yeah, anything that the LLM will do. But here we go. It's now saying it's now talking in pirate, which is amusing but not so easy to work with. So that is, yeah, one of the ways that we can then configure that. So now I've got an existing repository of code that has been created, but I want it to start using those instructions and have a look at the code and say, does it match with your instructions? So here I can say, please review the code with the new instructions. And it will go in pirate. That's going to get old quick. It's having a look, it's rereading in all of the configuration that it's previously written, and then it's going to start making modifications based on the instructions that it's been given. So for example, it's noticed that we don't have the file structure in the way that's required, we don't have the backend configuration as it should be, so it's now starting to reconfigure, which is nice. So all of this is happening without really any use of that Terraform key, the token that I put in. But if we wanted to have a look at, say, making some changes within my HCP environment, we could ask, first of all, you can have a look at the functions that are available. So we can create variable sets, we can create workspaces and tags. So let's say, can you list the workspaces available? And it will go out and it will query based on the context of the token that I've given them. It's listing the Terraform organizations. It's telling me what it's doing. And then it's found 3 workspaces. And it's giving you a little bit of information on those 3 workspaces. But it'll also tell you that the Terraform MCP demo is the one that it's configured to use at the moment. And the reason is because of the context of the token that I've given it. Let's make some changes. Let's please add variables for this code. I need to tell it to the workspace, but no, to the workspace it's doing it. So now it's making another change. It's doing something different, and I haven't allowed that specific action. So now it's saying, am I actually allowed to do this? So I'm going to say again, I'm going to allow it for this session. So it's reading the variables file, and it's going out and creating for me the variables. Now, working like this with the LLM and the MCP server, you can very, very quickly either assume control of an existing repository of Terraform code, understand it, get it to explain it to you, upgrade it to best practices, upgrade it to latest versions, and make sure everything is running according as you would expect, just simply with a few prompts. And as long as you're on top of approving those prompts, it's going to tell you what it's going to do, it's going to give you information, and you can either say yes or no, I want you to do that. Okay, so we have created our variables, so let's go and have a look at the variables page, he said. And there we go. So we have the variables that it's generated for the Snowflake database, which I couldn't have possibly known about before because it came from, it's like a magician's trick, isn't it? I couldn't possibly had it out my sleeve, couldn't pre-bake this. Those variables are in. They are a little bit short for that, yeah. Okay. So that's a little bit about how you can run on locally. I will also show you this MCP JSON. So here is exactly the same thing, running in Docker, running in the Mac container, running in Podman. This one here is running on Kubernetes. So this is a HTTP type rather than the standard I/O. And within the context of that Kubernetes deployment, I've already given it a Terraform token. So that service that is running in my lab at home in the UK is actually authorized to do certain things in a certain context. And as I mentioned, slightly preempting before, the reason you would want to do that is if you have a team of people developing stuff and you don't want to permit each one of those developers to have a local MCP server with a local authentication token to a particular production environment or a protected environment, you want to have everything gatekept through your MCP server. You can stick your OAuth or your tokens through there, and then you can protect it in that way. And that gives you the opportunity to have multiple clients hitting one server. You can also have that with authenticating to whatever different authentication system that's then using a context token. So let's go and I have a look here. So here we got, this is my Kubernetes cluster, which is 4 Raspberry Pis. Yes. And then within this, we have, in fact, so within this Terraform MCP namespace I've provided, I've got 3 Terraform MCP servers running. I've got a load balancer in front of them, and then I have OAuth authentication happening configured in the front of that load balancer. And that allows me to, I think I actually used my Google account, my HashiCorp Google account, to provide OAuth authentication to access my load balanced MCP server. And that's also been published as DNS, and there's a Let's Encrypt SSL certificate sitting in front of it. So you can treat it as a completely separate standalone service that then can be hit by multiple people. And then there's configuration variables, so you can have it run sticky sessions, and so when you're having context, you're going backwards and forwards with the same pod, or you can configure it to have stateless sessions effectively, so the context is dropped every time and it re-establishes the context. There are different arguments around why you should do that and you shouldn't. But that's another way of running the Kubernetes, the MCP server in Kubernetes. So,
Where did you get the Kubernetes service you're running? Is that something that HashiCorp provides, or you built it yourself?
so the one that's running on there, I built as a wonderfully curated, handcrafted service that I wrote myself. However, one of the things that I wanted to also show today is that I'm also publishing a unsupported, as is, not officially maintained set of Helm charts where you can start deploying your own HashiCorp MCP servers. And within there, you can actually deploy the Terraform one by itself. You can deploy the Vault one by itself, or you can deploy a single service in front of both and then use like a URL redirect. But it's just as an example of how you could run it if you would so desire. And that's basically because I was learning the MCP server. I do a lot of Kubernetes stuff. I wanted to figure stuff out. So that is available on my GitHub. So that's my name and then HashiCorp MCP servers Helm. But as it says at the top here, provided as is and not officially maintained by HashiCorp. So use it as your own peril.
So Sam, question. MCP is relatively new.
Yep.
What are some of the challenges you've seen when implementing this, or do you see challenges with MCP at all?
What in a sort of more broader context?
Yeah.
Well, I think I'm relatively new to MCP servers also, so I'm caveat with I'm just learning. In what I've seen so far, it seems like a reasonable standard that has been sort of made open by Anthropic, and there are a lot of people adopting it. That said, it's not mandatory to adopt it. It's not you don't necessarily not all of the LLM models will support agents. So agents seem to be the tide the way things are going. MCP servers seem to be the tide the way things are going, but AI is still like this big bubbling cloud of nebulous stuff, and it's not yet settled that MCP will be the way that things talk to each other. So if there's any kind of worry there and concern there, is that it may something new might come out in a month's time that's the new way of doing it, and it might supersede MCP. But for now, that seems to me the easy way to access.
Yeah. First, very nice shirt.
Thank you.
Very beautiful. The second thing is, what's the major difference between using like some agent, like Client, bot, or Copilot in agent mode, and running specific MCP servers for each of the tools or whatever we want to do? What's the major difference between using both of them?
I guess it's the way that you're using them. It's how it fits into your workflow. You don't want to provide. To me, it would be how you're using it, how you're working it into your workflow. I don't have any more specific answer than that. What are your thoughts on that? Is there?
Yeah, because for instance, I use Klein, and with Klein I can plug any LLM I want.
Yeah.
And Klein has the plan and the act mode. When I am running in the plan mode, I can give all the instructions and context, and it will generate the plan for me. When I switch to the act mode, it will create very workable solutions in most of the times. And I don't have to configure anything else. I just have to give the proper context and everything will work. So I'm trying to understand what's what exactly I'm gaining if I am using an MCP server for Terraform, one for Vault, one for AWS.
Yeah. So the MCP server will provide you with more accurate answers than you'll get from a generic set of queries. So you can put a simple request into Claude or any of the LLMs, and it will give you a reasonable effort. And a simple deployment, a simple set of instructions, is fine. Once you start importing a big code base into it, so managing hundreds or thousands of different objects and maybe some more eccentric ones, so you're not using just sort of like an AWS provider, but you're going off and you're using something a little bit more less mainstream, less likely to be in an LLM's kind of learning data set, you'll find that there are things that are either not done correctly or missed, or you have basically the hallucination problem where you have modules that are created out of thin air, but the modules don't exist. So I'll give you an example. I was using Claude to refactor an application we have internally. So we have a chatbot which we use to log our work. So internally we log our work. We're measured on a certain number of hours we influence. So we log these things on this chatbot. And the infrastructure for that was managed by Terraform, and we were kind of like using our own tools to make sure that we were. That's annoying me. Using our own tools to make sure that we were, dog fooding our own stuff. But the problem is that the person who had created this Terraform had left long before I joined the company, and it had been going along fine, and then it started to have problems, things started falling over. So my boss asked me, can you look at it? We need to get it stable. We need to reduce the cost because it was built way too big and all sorts of things. So I'm looking at it, and I start asking Claude to refactor things for me, to change things. And it starts with some helpful stuff, very quickly descends into the point where it's referencing things that don't exist. It's creating names for things that didn't exist, having that hallucination problem. It was fine with like your standard AWS EC2 instances because there's plenty of reference material kind of out there that it was trained on. But the more specific stuff and the best practice stuff were baked into the Terraform MCP server, and they're not there in the generic stuff. So hopefully that answers a little bit more clearly. I feel like I waffled a lot there and got distracted by my laptop, but does that answer your question?
Yeah, no, yeah. I think what I am getting here is that with the MCP, we are able to teach the LLM more skills or more precise ways of working, right?
Yeah, it's the precision, but also it's being able to reference documentation. The MCP server knows exactly how to access the most up-to-date list of providers and modules that's available in the public registries, but also if you're using enterprise or HCP, it's referencing your private ones as well. So if your company's built a private module for a specific internal API, the MCP server can reference that module, look at the documentation that's on your registry, and teach the LLM how to write for that. So it's accuracy, but it's also the ability to look up the most current information.
Okay, perfect. Thank you.
Let me just add one thing about the MCP. Like, one of the biggest differences is really what he said. Like, when you start working, like maybe Terraform it will be good answers, but I work a lot with Nomad, for example. If you start to ask questions for ChatGPT or Cloud by Nomad, it will simply create something out of his head, and it will not work. It simply thinks, yeah, you should use whatever function that never exists. So when you have the MCP, it sort of like references the documentation, and it's sort of, let's say, specialist AI that will give you more accurate results. It doesn't mean that it will not give you wrong results, but it's less likely that you will spend more time on it, I would say.
I actually was trying to use the MCP server for Terraform a little while ago. So I'm not sure if my experience still is relevant or it is fixed, but something that I ran into was that, well, of course, one of the tools is get the documentation for a module or a provider, and sometimes the information that was returned by the MCP tool was too long to be processed with the LLM. So I would like to ask if this is something that you recently ran into, and if you know if there is a workaround for that. Apart from, the documentation is written by third parties, and that has probably need to be adapted to like an AI-friendly format. But yeah.
It's not something that I've run into, and I mean I have been experimenting with trying to use the MCP server with the smallest models and the least capable models that I can. So I'm running like LM Studio on my laptop with as smaller models, models as possibly can, and I haven't run into the problem where it's run out of context. So I don't know when that was. Maybe some of the earlier versions, or.
I think it is. I'm not sure it is the exact one that you showed here that's running. The version seems to be the same, what I have from back then and what you're showing today. But I basically have an executable, not the container. And for the MCP tools, I noticed that I have a few tools versus what you showed was, I think, 30-something tools. So there's definitely a difference, but I don't exactly know where.
Yeah, so I know at HashiCorp we kind of announced the MCP server stuff. I know that it's been actively developed. I couldn't tell you what the difference between the point versions is at the moment. If you run into it again, feel free to you can ping me, and I can feed it into the product team, because he's been quite helpful. The product managers for it's been helping me with various things. So I've got a good channel into him. So yeah, if it's something that you kind of continue to see, for sure, let me know, and I'll do my best to figure out an answer.
Yeah, thanks.
All right. Do we have any more questions? Anyone? Comments? Anyone want to throw something? Not you two.
Are you aware of any future MCP servers that are going to come out of HashiCorp in the near future?
I am not aware of any new ones. That I would imagine that the team working on the MCP service is focusing on the core products around Terraform Vault, but probably in the order of scale of the products that are being used. I would have guessed. Don't quote me on that. Cool. Okay, well, thank you for your time today and for listening to me, and I hope you got something out of that.
So now we have a small break for people that are online. We'll be back soon, I guess, right? 10 minutes. So we'll be back in 10 minutes for the next talk.
welcome back to our second exciting speaker, whose name I'm going to butcher. So perhaps you should say your own name.
Yes, the name is Ivica.
Ivica.
That's it?
Yep.
Perfect. Well, I'm going to be talking to you about fashion today, so that's why I try to dress well and also not to bore you. I promise that I have way more slides than the previous speaker. I have way less demos, but I think they're pretty, so at least we have that going, right? What I would ask you is to imagine your wardrobe and ask yourself, like, how many white shirts do you have and how many white shirts do you need? Right? And I guess a good number is like 4 if you're a regular person who likes to dress well. But if you would ask the same question to a buyer that works for a fashion enterprise, the answer would probably go from 4 to, because this is not an easy number to guesstimate, right? Because there are many variables that affect the number of white shirts that a fashion brand can sell. And to make it even more difficult to answer, they need to guess this number for 7 months from now, because that's how the fashion industry works, right? Seasons, and you always do for 2 seasons ahead. To make it almost impossible to answer, you work as a buyer for a fashion enterprise that has 20 brands under its roof. Each one of them has tens of thousands of clothes, and you need to estimate their number 7 months in advance. And these clothes are going to be sold through retail stores, they're going to be sold through e-commerce web shops, but they're also going to be sold wholesale, like to partners and to associates. The only way that you can do this and that you can guess this number correctly is by being data-driven about it, because every other way is going to be wrong. As a matter of fact, the data-driven way is also going to be wrong, but just the smallest amount. Because when it comes to selling clothes for a living, you absolutely need to have the right product at the right time, show it to the right customer, but also for the right price that they are willing to pay. The consequences of being wrong are going to be felt throughout the world, because this is a big enterprise. They produce and sell millions of clothing items. So if you make 1 million more or 1 million less, there's going to be more CO2 used, more water used, but there's also going to be a commercial impact on your business if you have too few clothes to sell and people want to give you money, but you don't have the shirts. Or if you order too many and then you simply cannot sell them, right? The fashion brand, this fashion enterprise that I'm talking about is built up of 20 companies, essentially 20 startups that are trying to work together. And why I say 20 companies, because they all have their own separate employees, their own separate budgets, their own separate decision-making processes, which gives them the agility to deliver quickly, to make business decisions like on the spot. That's great for the business. Where it isn't so great is when you don't have a central place from where the technical decisions are governed, such as about data storage systems. So that's when you end up with having small databases, big databases, those in the cloud, those on-premise. Some of them are unavailable. You have Excel files on the laptop, and it's all considered data sources that you should use as a buyer to estimate the number of white shirts that you need to order. And that's impossible. You need very good data to have a very good number. But you cannot have very good data if that data is siloed, unavailable, not governed properly. And I think you see where this is going. We realized this, and we decided as a company to build a unified data and analytics platform that is going to serve all of these 20 fashion brands, something that will help them turn this data that is kind of a byproduct of their business into an integral part of the business, something that's going to give them answers to the questions that they may be having, such as, how many white shirts do I need? So we decided to break down these silos. We decided to provide actionable data to anyone in the company that needs it. And we also decided to build it with Terraform. And today I would very much like to show you why we think of Terraform as a game changer for us while building this data and analytics platform in a fashion enterprise, and how it worked for us. So who's us? The company is called BESTSELLER. It implies that we are best at selling. How many of you have heard of this company? 1, 2 hands. I know you work there. You might be lying. I don't know. Just kidding. Yeah, that's usually the answer we get. But essentially, it is the company that is behind these fashion brands. Like if you bought anything from Jack & Jones or Villa or Mamalicious or Name It or any of the 17 others, thank you. You've paid my salary. My name is Ivica, and I work as a lead infrastructure engineer that is still building this data platform and using Terraform to make it so, to help brands and to help people that work for those brands answer questions about their business. But what my team delivers is infrastructure, tools, processes, standards, something that doesn't have, direct value to the business. That's why there's an army of data engineers that are going to be using those tools and processes to crunch the numbers, to parse data, to clean it up, to massage it, to make data products out of it. And when I say a data product, it might sound silly, like, what is it? I'm an engineer. I like to know what things are. Think of it as a view in a database, a schema in a database, an Excel file that you can use that will tell you the right information that has value. Like that's data that is clean and that has value on it. Those data products on their own don't really do anything, but that's why we have an even bigger army of data analysts, of business analysts that are going to be querying those data sets, using those data products to essentially draw conclusions, to get numbers, to get trends, to understand the past, and to try to predict the future, both of very difficult to do. But in the end, those conclusions will be used by the management team, the topmost layers of the management team, to make decisions about the business. Which country do we expand to? Which carrier do we use to deliver our packages? Why is the return rate so high? Right? These are essential questions to the business. And the data platform is there to help people that understand data answer those questions. In its most basic form, a data platform enables this: loading of raw data, transforming it, cleaning it up, massaging it, making it useful, and in the end, serving this as data products to whoever might need it. The success of this platform is going to depend on the number of producers of data and the number of consumers. The platform on its own has no value. So having that in mind, we were also very critical when we were deciding on the tools and the processes that will help these teams and these people use the platform itself. So by standardizing on a good number of things, we help them move faster while also keeping the platform secure and governable. So we've talked about the producers of data and consumers of data, and the way we typically separate them is into domains, such as the retail domain or the finance domain or logistics or anything that you can come up with. So you would be very right to ask a question, what is a domain? Again, I'm an engineer. I like to know what things are under the hood. So what is a domain in practice? So it very much depends on who you ask, right? If I was a security engineer, I would say it's a security boundary because it does guard your data with tools and protocols. If you ask a typical data engineer, what is a domain, they would tell you, hey, it's just a grouping of data that belongs to the same category. E-commerce, retail, logistics, these are all similar data that belongs together. And if you're something like me, like a platform DevOps engineer, it's just a bunch of Azure AD groups, Snowflake roles that do the thing that you want to provide to your consumers. And the first reason why we think Terraform is a game changer for us is because we can take this fundamental building block of the platform, the domain, and we can treat it as infrastructure. We can manage it with Terraform. Super nice. So what you see on the screen is an example, a real module, a real example that creates, for example, the finance domain with a few owners. 2 in this case, John and Jane. In a nutshell, this domain is going to create 10, 15, 20, I don't care about how many resources, But that's not really the point. The point is what it enables for the company and what it enables for the platform. First of all, by setting very clear ownership, it allows anyone outside of this domain to understand who owns the data, who is responsible for the quality, who should they contact if they want access to this data. On the other hand, by using Snowflake roles, sets up the correct permission structure, role-based access control, and it enables governance for us centrally, again, through code, through Terraform. And because it's a module, what you get self-service. You get growth. As a matter of fact, my team, I don't remember when was the last time in the last 3 years when we used the module. It's always our stakeholders that use it because they know what should constitute a domain, so they just create them on the fly whenever needed. But the domain on its own doesn't really do much. That's why we need the almighty database, and that's why I asked Sam, hey, can you generate for us a Snowflake database and a few roles, because I wanted to see if I'm going to be out of a job. No. That's good to know. It was cool seeing it, but there's a lot more to it than just simply creating databases and roles. So what we have to recognize here is that the database is, that's why I call it the almighty, that's where the value is. That's where the data is going to be. So it is a core of a domain. And again, we can manage this with Terraform. Again, a module with a few simple inputs. It allows our stakeholders to use this. And the number of resources, 50 plus, I don't even know, 20 data sources to make it all work, to make it all happen. But what it enables for the business is far more important because it enables sustainable growth through, again, being self-serviceable. Use the module, provision what you need, go about and do your job. 10 minutes, you're up and running. No need to involve anyone else, right? That's the beauty of Terraform and modules. But by also using this as a cookie cutter template, we can put governance layer on top of this. We can put tags so that we can do cost reporting centrally, cost optimization centrally as well. And by building two databases together, what you start to create is called a data mesh, where you have two of them. You can combine the data from both, to put it simply. So to give you an example of this, if we look at the two domains that I mentioned in the beginning, the one being retail, you could always have a brand manager, let's say someone sitting in the Jack and Jones office, and they ask, how many shirts did we sell last year? It's a fair question. They want to understand how they did, how their products are doing. But if you can do this with just one database, imagine what you can do with two, or what you can do with 10. So to just extend the example to having the retail and finance domains, you can now answer the first question, how many of them did we sell? How much did we earn on them? Oh, and by the way, are the red ones a good product? So you can filter this data and you can very quickly understand how is the portfolio of your products doing. Could be fashion, could be car tires, could be, I don't know, ACs, whatever. The principles stay the same. How does the data mesh look like with Terraform? Well, it's quite simple. The database that is going to be written to by someone working in the finance domain, they own this, they know what should be inserted. And we said, okay, someone sitting in the retail domain or someone working for Jack and Jones would like to read, so we can simply grant them the permissions to read this data set by making this code change. For us, this is the game changer number 2, because the data mesh is born, and it's also allowing for infinite combinations. If you have 5 domains, if you have 50, if you have 500, the combinations are really going to be infinite in the answers that you can deliver to your management team. So you could do things such as combine the e-commerce, the wholesale, and the retail numbers, and you can definitively answer the question, how many shirts in total did we sell across all sales channels? You could also go a step above. You could combine these 3 domains, such as HR, where you can get people working hours. You can combine the data from the legal domain, such as what's the price of this retail store monthly? So we're paying a lease. So how much are we paying in the leasing contract? And also, how much did we sell in that particular store so you can understand which stores are profitable. And why is this important? Well, it's important because the business is ambitious. And one of the goals, and I hope I don't get in trouble for sharing this, is to open 2,000 retail stores a year. So if you open 2,000 of them, you absolutely want to understand how much of them are profitable and which aren't, right? Combinations are really infinite. Terraform allows this, right? And this data mesh is managed with code, which means that, again, we get all the benefits of using code, right? You get version control. We get to use code owner's feature of GitHub, giving a owner of a domain full ownership of who can access their data. Because managed through code, there's a pull request, and they can simply reject and say, no can do, mister. There's sensitive data here, you cannot see it. One of the first challenges in the past 2.5 years was, of course, this one. Every stakeholder ever has said, I don't know Terraform. And that's very fair. These people do data engineering, they do SQLs of 1,000 lines, they know their stuff, but they're not Terraform users. So we definitely understood that there needs to be an asymmetric complexity in the way we build things. For us, the complexity should be high. This is what we deal with, this is what we do every day. But for our users, the complexity should absolutely be low. And this is a simple approach that we are trying to use every day. When designing these modules, go with a simple interface. Go with the safe defaults. Code that you don't have to maintain is the best code. For our stakeholders, if they can change one line, that's good. If they can change 0 lines, that's even better. Use as much data sources as you can, and also use a similar interface across all of your modules. We have around 20 of them. And then again, share knowledge. Do the documentation, right? But no one likes to read. So do trainings, do office hours, do success stories. Find champions within the teams that are using your tool, using your module, and have them tell the story. It's going to sound better because it's one of them saying it. It's not you, saying my horse is the best. And of course, version the modules, right? It's a good practice. It's what you should be doing. Yes, to keep breaking changes behind the feature flag, but also so that your stakeholders don't experience failure, because you have control here. And if they are unsure about Terraform as a tool, if they see a plan that has something red in it, they will gonna say, not my job, please come fix this, and it will be a sore thumb in their developer experience and in their user journey. Cool. So as I said, it's all about minimizing the cognitive load. So looking at the example of this finance domain module, the only thing that our stakeholders need to change is these lines. Again, simple lines. It's a simple array. If you come from any coding background, you would have an easy time making this change. Absolutely. The same goes for the Snowflake database module. Again, the only thing they need to touch is these lines. Copy-pastable, absolutely. To also not to downplay it too much, the same database module can be quite complex in the interface, because if you really want to nail down who can see what and when, you can absolutely complicate it. So you could grant different roles to have the write permissions. You could have multiple roles having read permissions, but you can also have per schema permissions. If you want to limit what one fashion brand can see in terms of data, you would put that specific data into a single schema and allow them only to see that schema. There's laws around it. You absolutely have to do it. Otherwise, 1.5% of your revenue is the fine. Good. As I said, another thing that we are trying to do is to keep the module interface consistent. So what you see on the left is the module where the analytics database is created. On the right, it's a storage account for on Azure. Same interface, almost copy-pastable across them. It goes even further. Even the permissions to the database and to the storage account are also managed in the same way. Even though behind the scenes, right, everything is it's different resources, differently implemented. It's a different third-party provider after all. But for the end user, for our stakeholder, looks the same, feels the same. Good. Another challenge was being far too downstream in the release process. So when Snowflake releases something, a feature, I think it goes roughly like this, don't quote me on that. It goes into public preview, then GA, then it becomes available on AWS, then Azure, and then finally it lands in Terraform, and each one of these can really take months. And we are, of course, here on the back of the queue. It gives us time to understand the feature from the documentation before it lands in our lab, right? But it also creates this friction because, as I said, this is 20 startups working together. This is 20 startups competing against one another and then competing with their competitors on the market. So one of them grows big, congrats. And all of a sudden they need a new feature, hybrid tables in this case. We have to provide it, but this is AWS only, and we are on Azure. There's two options for us, right? We can just tell them, come here next year, and I cannot swear because we are all live, right? But they will be very colorful in their language. We can always tell them, hey, go somewhere else, and they will be happy to because it's business. They need to deliver. They don't care about Terraform or Azure or Snowflake or whatever. That's not what gives value. Or we can do something like this. I hope you can read it in the back. I tried to make it a bit bigger. You try and see how it goes, because this feature is available on AWS. So I have my colleague, he sat down, he tried to build this. Roughly 28 minutes later, I see the CI is green, I see Terraform plan happily saying, I'm gonna change this and that, I'm gonna add this and that. And I even comment, you cannot see this, but this is working too well, because I'm stumped, I'm surprised, why is this working? 28 minutes later. So what happened in those 28 minutes? If you're working with Terraform, this is old news to you. You use this every day. Create a provider, give it an alias, use that alias provider with your module, boom, it works. What happened is in those 28 minutes is we became multi-cloud data analytics. We were running on Azure and we were running on AWS, like this. They gained competitive advantage in 28 minutes because they got their feature that they wanted. They got better performance out of this feature. They got lower cost in 28 minutes. We got some bragging rights. I can come to an event like this and I can speak about it. But this is why Terraform is a game changer for us, because we could deliver all of this with a simple feature of a tool that you have been using every day. But the end result is huge for them because they get all of the benefits of being multi-cloud, of being competitive, and of having a lower cost while doing so. Another challenge that we were facing was that the Snowflake provider was under heavy development. For 2 years, 2.5 years, very heavy development. And you can say it's a good thing, right? Because you get new resources, you get improved security. You also see commitment from the company because Terraform is an interface. If I had to click through the UI or use SQL, God forbid, I wouldn't be employed, right? But because I can do it with Terraform, it shows commitment. It broadens the user base. It also means that you get breaking changes in a version such as this one. Not cool, really not cool. We also saw some amazing growth in 2.5 years. We grew 4 times over in every possible way. New stakeholders, new domains, data sources, data products, pull requests, 2,000 of them. Super nice. But we had to stop upgrading the provider because of those breaking changes, because of the pace of development, because with every new upgrade, we were getting more and more deprecated resources, and it just was scary. Dudes, I can tell you it was scary, and you'll figure out why soon enough. Then when version 1.0 was announced, a stable version, plenty of breaking changes, it was really time for us to migrate. For us to stop the growth for a bit, focus on getting it stable, focus on getting it ready for the next phase of growth. But we also had 5,000 deprecated resources, and we were 2 years behind on all possible upgrades, like everything. We missed everything to allow for this growth to happen, right? It was a trade-off. So the migration kind of looks like this. You have 3 layers that you need to change and reconcile to be up to date. There's your Terraform code in your modules, in your resources, whatever. Most of the time, this will change. There were plenty of breaking changes, plenty feature changes, all good, all in your control. Then there are the Terraform resources in the state for the Snowflake objects that were created, and this might change. Still good, still all right, but then you have a live system that must not change. You have an amazing growth, you have 60 domains, you have 1,000 stakeholders, roughly, and they depend on this. This is live, this is in production. Good. This is a statement, and let me see a show of hands who thinks this was a difficult thing to do. Upgrading 5,000 resources across 3 environments on a live system in 1 month. Was it difficult? Okay, a few of you are brave enough. One more, thank you. Actually, it was boring. It really became boring. The first week was rough and tumble until you figure it out. But because we had these version templates, the change needed to happen in one place and then propagate it. We were fully in control. We also had very strict environment separation, so we could, play around, learn in dev, see how it goes in test, and then and only then roll it out to production. We are also very streaky and nitpicky, and that's my whatever diagnose hitting there, but there is a very consistent naming scheme across everything. And people hate me for that, but yeah, I get to reap the benefits of that, because when you have a consistent naming scheme, you can do greps, you can do counts, you can do all the good stuff with all the good tools that you develop or that you did not develop, so you can just automate this. Once you have a process that works, it's a bash script, it's 2 for loops, it's done. And also, it was easy because we built 2 helper tools to help us go through this. One of them is open source. I'm going to plug it in soon. This is where we realized that Terraform is a game changer for us, and it is the way for us because it is not in the way for us. It does enough, but not too much. It allows you to build and rebuild and evolve. Want to change the state? Want to be a surgeon? Cool, go ahead. It's open for you. I was searching for some features in the language itself, in the tool itself. And more often than not, I saw core contributors or maintainers of Terraform reject pull requests, reject requests for features. And the reason was simple enough. We don't want to bloat the tool with this. It's a cool thing. We applaud you. We thank you for the contribution, but it maybe belongs in a provider of its own and not in the core feature set. That's a very mature thing to do. Because by doing this, what they are doing is they are balancing what the tool can do and what it cannot do. And because of that, it plays along nicely with your grep, with your JQ. It plays along nicely with the tools that were built 50 years ago. By using JSON as the output, it plays along with almost anything that is available today. such as the tool that I've open sourced. Who uses Terraform Validate here? Good, nice, as you should be. I love it. It was an instrumental tool in upgrading these 5,000 resources because it will tell me, hey, this is what's wrong. This is where you go and fix it. It's native to the tool. It's native in the ecosystem. It outputs as JSON, so perfect. But in my case, it was 50,000 lines of JSON. That was a bit too much for me to look at. And I thought, okay, I can do something around this. I can build a simple tool, a GUI tool, because I want to share this with the world. Not everyone is a fan of a CLI, that allows you to open this output and filter it. Search through it, figure out what resources, what warnings do you have, what errors do you have, and which resources are going to be affected. So by opening my test file, I can see that it has like 2,000 warnings. That's a big number. But actually, if you search for a specific resource name, so let's say that you want to fix, I don't know, an AWS VPC, or you want to upgrade the security group resource, whatever, Snowflake in this case. You search for the resource name, you say, show me everything that contains this string, and all of a sudden you go from 2,000 resources to just 60, which is way easier to deal with and to work with and to put in your brain. But you also can use the only unique toggle, which will again show you just unique version of this resource, of the warning about this resource itself. So you go from 2,000 to 1. And because it's just 1, it shows you where exactly this resource is. Open the module, fix it, run validate again, all green, all good. So you went from 2,000 warnings to a fix by using this simple tool. Good. One of the major goals for Bestseller as a company is to be sustainable in every possible way. Production, energy generation, but also the way we build our systems and the way we build our platforms. Being sustainable in that case means that adding new data products doesn't mean that you need to hire more data engineers. If you need new features on the platform, it doesn't mean that you need to hire more platform engineers. Do more with less. So, what is more, what is less? I can tell you that we have been outnumbered for the past 2.5 years. On and off, we were 3 engineers in the team. That's it. We directly serve 70 to 80 stakeholders within our department. So these are the people that will do crunching of the numbers. These are machine learning scientists. These are the people that are hardcore data enthusiasts. What they have is roughly 1,000 stakeholders, direct stakeholders that will use the data products that they have built. And in the end, the business itself is several billion euros in turnover every year with 3 engineers in the platform. I think that's the definition of being sustainable, and that is where we saw that Terraform really is a game changer for us because it is a great amplifier of what we are doing. Build a module once, validate that it works, and give it to your stakeholders so that they can generate value with it. It doesn't matter what it is as long as it generates value. We saw that it works, absolutely. A data analytics platform can be built with Terraform successfully, but we also saw that it's far from perfect, right? I'm not going to lie to you. So what's next for us is isolation, smaller states, faster applies without an approval maybe, because at the moment code is it's a monorepo. It's a bunch of Terraform files. 200,000 lines easily of Terraform. It's too big for anyone to understand. So we need to break it apart. We need to keep it smaller. We also saw that our modules need to be reworked because when we started building them, we didn't know what we didn't know. And our stakeholders didn't know what they don't know. So we went very wide. We went very simple, big Lego blocks. One module does one thing and one thing only. But now we think it's time to make them do more than one thing, make them easier to use for humans, but also for automation. Just today we saw an MCP server example. So if you build your modules to be usable by something like AI models, we can have even more growth. Absolutely more policies, more checks, more rules. That means I don't have to look at the pull request, I don't have to look at the CI run. Again, more growth and faster growth as well. There is also a big plan for us to now go from 70, 80 direct stakeholders to a department with 400. So that's a big step up. We have opened one more spot in the team. So we think, if we can handle 70, 80 with 3 people, we should be able to handle 400 with 4 people. Why not? Let's try it. Good. So to get to the takeaways, I have a little story for you. I live very close to the Schiphol airport. Lovely airport. I'm so close that when a plane lands, and if I look at it, I can see the windows. I can see the company name that it belongs to. My daughter loves them. She's just like, and they are frequent, right? So a question for you. When you look at the Schiphol airport, it has 6 runways. Those in purple, what do you think? Are they used for landing? And those in gray are used for taking off. Who thinks this is correct? Okay, 3 hands up. So I'm just going to do an inverse. The purple runways are for taking off and gray runways are for landing. Is this true? No. You're all right. But also looking at the scale of the airport, they have roughly 1 takeoff or landing every minute, 365, 24/7. So it's a busy airport. But it was a trick question, because all runways are used for landing and for taking off. Right? That's what you meant, I think.
Yeah, with the wind direction.
Absolutely. And also with other factors as well. So wind direction, time of the day. People living around are complaining about the noise. So that's why you don't see big cargo planes landing at 3 in the morning. It would wake everyone up, right? So what the management of the airport is doing is they are adapting to humans and to nature. They are planning, they are measuring, and they are adapting. And I think this holds true for the data and analytics platform that we built with Terraform. If you know your stakeholders and if you tailor the platform to them, if you treat everything as infrastructure, and in the end, if you plan and measure and adapt, you can do this. You can win this. But if you also think about, are you building the right thing wrong, or are you building the wrong thing right? With these words, I would like to thank you very much for staying until the end. If you want to hit me up here. It was a pleasure. Do we have any questions? Please.
What were some of the biggest challenges or issues that you faced offering Terraform to other teams, so they had to use it like that?
They ranged from, I understand Terraform, but I don't like it. I have an opinion about it, and that's it. I can copy-paste, that's good. To people saying, I don't care about your plan. I don't understand it. I don't want to think about it. I want it to be a magic wand. And then I would, if I were to phrase it differently, there's a different skill and competency set across all of these stakeholders and across all of these teams. Some people will naturally enjoy doing something else other than SQL and Python. Some of them will not care about it. So ultimately, it's our job to help them along. Even though everything is self-service, ultimately it is our job to help them set everything up.
And what eventually convinced them, or were they forced to use it?
There was no force, right? There's no force. It is a collection of tools and standards, but it's not a collection of, handcuffs or whatnot. you try to share success stories. You try to show the impact. We have recently had a, how do I explain this? Service accounts for machines connecting to Snowflake. They should be using private keys, no passwords. And this is something that comes from Snowflake as a platform for increased security, etc. But there is now a transitionary period, and every once in a while, we would migrate some of those from passwords to using keys. We did it in such a way with Terraform so that when I update the service account, any connection to Snowflake is also going to get updated to automatically use this private key. So no change for the end user. Unless you as the end user do not manage your connections with Terraform. You do it clicky, clicky, we make a change, password doesn't work anymore, and you get woken up by PagerDuty because your data pipeline didn't go through. So instead of telling them, no, you have to change this, you approach it from the impact. Like, if you manage this through code, it is seamless. Rotation of the credentials, you do not see it, you do not feel it. And your data pipeline doesn't get broken. The report that goes to the CEO, like literally in this case, doesn't get broken. So it's not a matter of you have to, but you should, and here's why. Anyone else? Pizza time, I guess. Thank you very much again for being here.
Thank you for your amazing talk, indeed. Well, I'm not going to say the word, because then you'll lose focus on what I'll be telling you right now. Yeah. I'm going to close the day with a couple of announcements still. First of all, thank you for coming again. I thought it was an amazing event. Great speakers today. Being a real man, I can't do two things at the same time, so. Yes, we're wrapping up today. So, thanks for coming. Please come again. I have one thing to advertise. Being a community event, of course, Hashi, the community team, has a community conference every year, runs for 24 hours. There's a new speaker every 30 minutes, and the RFP is still open. So if you feel like you want to discuss all things Hashi, feel free to submit your abstract. I've managed to speak every year since 2019. It's amazing. Yeah, so please send in. It's for new speakers. It's for recurring speakers. And if you want your abstract reviewed, I'm more than happy to do so. And that really brings us to the end. If you have any feedback, suggestions, email the email address, which we promised we'll look at. So that's the end for today. There'll be food, glorious food at the end, outside, so please stay.
If you haven't picked up a shirt,
Yes, there's.
We're not planning to take a lot of stock.
Yes.
Back, so if you need 2 pairs, please.
Yeah.
Stickers.
Yeah. Pretend you're a student again and go nuts. Like we're not taking it home. We have a hard stop at 7:30. If you're still here in the building, a very burly security man will escort you off the premises. But until then, enjoy. There's drinks, food, alcohol. Did I say food? Yeah, I was asked to say there's a lot of food, so please eat our food. Thank you.